Scene script. Have you ever gazed up at the night sky and wondered just how vast the universe truly is? Picture this, a balloon. Now imagine that balloon expanding. This is a simple yet powerful analogy for the universe. It's not just vast but ever increasing in size, a thought that's as baffling as it is exciting. Picture endless galaxies, stars, and planets all part of a cosmic ballet, dancing to the rhythm of expansion. It's an unfathomable concept, isn't it? Now let's introduce a term you've probably heard before. Light years. Don't let the word year fool you. This is not a measure of time but rather a measure of distance. A light year is the distance that light, which moves at the swift pace of 186,000 miles per second, can travel in a single year. To give you an idea of just how far that is, consider this. If you were to travel at the speed of light, you could circle the Earth over 7 times in just 1 second. Now imagine covering that distance for an entire year. That's a light year. Scientists use light years to measure distances in the universe, a place where our everyday units of measurement fall short. They allow us to comprehend the incomprehensible, to make sense of the sprawling cosmic canvas that is our universe. But here's the catch. The universe is not sitting still. It's expanding. This means that even as we speak, the universe is getting bigger. Galaxies are moving away from each other, causing the distances between them to increase. This constant expansion adds another layer of complexity to the already challenging task of determining the size of the universe. So, with the universe's constant expansion, we can only estimate its size, but don't let that deter you. The universe may be vast, its size may be mind-boggling, but it's this very enormity that makes it so intriguing. So, let's delve deeper. Let's continue our cosmic journey and attempt to unravel the mysteries of the universe. To comprehend the universe's size, we first need to grasp what a light year is. So what exactly is a light year? Despite what the term might suggest, a light year isn't a measure of time but of distance. It's the total distance that light can travel in a single year. Now, light is incredibly fast. It zips around at a speed of about 186,000 miles per second. Yes, you heard it right, miles per second, not per hour. To put that into perspective, if you could travel at the speed of light, you could go around the Earth about 7.5 times in just 1 second. Now imagine maintaining that speed for an entire year. That's a light year. It's a distance so vast it's almost unimaginable. Now let's think about this in terms of miles. A light year is about 6 trillion miles. That's a 6 with 12 zeros behind it. It's such an enormous number that it's hard to fathom. But let's give it a try. If you were to get in your car and drive non-stop at 60 miles per hour, it would take you over 11 million years to travel 1 light year. And remember, that's without any pit stops. Now why is this important when we're talking about the size of the universe? Well, the universe is so incredibly vast that we need to use light years to measure it. The distances between stars, galaxies, and other celestial bodies are so immense that using miles or kilometers just wouldn't cut it. So, in essence, a light year gives us a way to measure these unfathomable distances. It's a kind of cosmic yardstick, if you will. It allows us to bridge the gap between the human scale and the cosmic scale, giving us a glimpse into the vastness of the universe. Now that we understand light years, we can start talking about the universe's size. The observable universe gives us a glimpse into the vastness of space. It's like peeking through a cosmic keyhole, attempting to comprehend the sheer scale of the cosmos. The observable universe is the part of the universe that we can currently see from Earth. It's the universe's stage that has been unveiled to our eyes and telescopes, thanks to the traveling light that has reached us. Now, imagine light as a cosmic messenger. It's been traveling across the universe, carrying stories from distant stars and galaxies. The speed of light is roughly 186,000 miles per second, which is quite a pace. Now, when we say that something is a certain number of light years away, we're referring to the distance that light would travel in a year. Given this cosmic speed limit, the farthest we can see into the universe is about 13.8 billion light years. This number isn't arbitrary. It's based on the age of the universe, which is estimated to be around 13.8 billion years old. Therefore, the light we're seeing from the most distant objects has been traveling towards us for 13.8 billion years. So, how big is the observable universe? Well, it's a sphere with a radius of about 46.5 billion light years. You might be wondering, how can the radius be larger than the age of the universe? Good question. It's because of the expansion of the universe. As light from distant galaxies has been journeying towards us, the universe has been expanding, stretching the distance that the light has traveled. But here's a humbling thought. The observable universe, as mind-bogglingly vast as it is, represents just a tiny fraction of the entire universe. Scientists believe that the whole universe is infinitely larger, possibly even infinite in size. But remember, the observable universe is just a tiny fraction of the entire universe. What lies beyond the observable universe? That's where things get even more intriguing. As we venture beyond the observable universe, we step into the realm of the unknown, where theories and hypotheses abound. This is a place where our scientific instruments can't reach and our understanding of the universe is challenged. So what could possibly lie beyond the observable universe? Well, one theory suggests that the universe isn't just what we see, but rather it's part of a larger multiverse. This multiverse is a collection of universes, each with its own laws of physics. Some could be similar to ours, while others could be radically different. But remember, this is just a theory, and while it's fascinating, it's yet to be proven. Now let's take a moment to ponder the overall size of the universe. Is it infinite or finite? That's a question that's been puzzling scientists for centuries. If we consider the universe to be finite, then it would suggest that if you travel far enough, you would eventually return to your starting point, much like circumnavigating the Earth. However, this idea doesn't quite sit well with our understanding of space. On the other hand, if the universe is infinite, it implies that it has no boundaries, no edges. It goes on forever. This concept is mind-boggling, as it suggests that there are an infinite number of galaxies, stars, and perhaps even an infinite number of versions of you and me. But hold on, there's another twist. Some theories propose that the universe could be both finite and infinite at the same time. According to the theory of relativity, the universe could be finite in volume, yet unbounded, much like the surface of a sphere. These theories, while fascinating, are yet to be proven. We're still at the frontier of understanding the true nature of the universe. But one thing's for sure, the more we learn, the more we realize how much there's still to discover. The size of the universe, whether infinite or finite, is a concept that challenges our understanding of space and time. Knowing the universe's vastness, where do we fit into the grand scheme of things? This question is a humbling one, isn't it? It's easy to feel insignificant when we consider just how large the universe truly is. We're just one species, on one planet, orbiting one star, in one galaxy, among hundreds of billions of galaxies in the observable universe. Our planet, Earth, is but a tiny speck in the grand cosmic tapestry. If we were to compare the universe's size to Earth, it would be like comparing the size of the entire Earth to a single atom. Earth is just that small. Yet, it is our home, our oasis in the cosmos, the only place we know of that harbors life. Now let's take a step back and look at our galaxy, the Milky Way. It's a large spiral galaxy, home to hundreds of billions of stars, and it's just one of countless galaxies in the universe. Even within our own galaxy, Earth is not in a central position. We're located in the outskirts, about halfway along one of the galaxy's spiral arms. Yet, despite our small size and less than central location, we are able to observe and understand the universe's vastness. We can measure light years, observe distant galaxies, and ponder what lies beyond the observable universe. This ability to understand, to learn, to wonder, that's what makes us significant. We may be small, but our capacity to comprehend the universe is immense. It's this understanding that helps us appreciate our place in the universe. We're part of something much larger, much grander than ourselves. Our existence is a testament to the universe's incredible complexity and beauty. So the next time you gaze at the stars, remember, you're a small part of a vast, possibly infinite universe. But also remember that it's your ability to understand, to wonder, and to explore that makes you, and all of us, truly significant.